Hello, everyone, and welcome. My name is Nathan, otherwise known as Old Man Builds. The benefactor will be here shortly. And today, man, we're going to have a cool show. I'm going to kind of go through some things I've been talking about lately, and we're going to build out some energy and show you how some things work. Sean's got some health issues. He may be in the chat a little later. He had an appointment today, but he won't be presenting today. It'll be me. So anyway, we're going to go over some cool things out there. I just wanted to take some time here for a minute and say thank you to the members on Ben's channel and also the members on mine. So give me a second real quick. Here's all the members on Ben's channel right here. He's also one member away from unlocking another emoji. So if you're interested, hit him up and get there as a member on his channel. Also on my channel, just lets you know, we're doing real good on our memberships there as well. Also on my Patreon. Guys, a lot of information going on some of those on my channel right now. I just cleared out all the membership stuff because I'm getting ready to add new stuff tomorrow. I got a whole big day of testing coming up tomorrow, so it's going to be pretty fun. But I wanted to say thank you to all the members on both. You guys are awesome. You guys make this thing happen, guys, along with everybody in the chat and everybody that watches. I just want to say thank you. Anyway, with that said, guys, let's go ahead and get into it. And I got a cool video for you today, and then we'll talk about it. Let's talk today about your Tesla coil. I'm going to show you a few things that you may not understand about them, or some things you may have seen, but don't understand how to put it together. So let's go ahead and take a look. If I draw this, then I draw this, do you know what that is? Well, it just looks like a mess. That's what it looks like, right? Now let's do this a little better. Just put it a little closer together. And then we'll use a different color here, but we'll do the same thing. So what am I showing you here? Well, this is okay. Oh, I get it. Yeah, that's the ring of your Tesla coil. So what's this other nonsense you're drawing up there? This is the ring of your number one coil. You're ringing at one frequency in order to match the frequency of your number two coil. Pretty interesting, right? This is the way it shows up on your oscilloscope. You have a probe over here to your number one coil. You have a probe to your number two coil. What do we generally see? We only see the number one coil. And we know that when it spikes, we put it in resonance. So you may get a little bit like this. You go, man, that's garbage. That's never going to work for us. Okay. What if we got this? You go, okay. Well, now we're getting somewhere. Okay. We're getting close. You go, okay, now I got some resonance frequency. But what am I actually showing you? If I told you these were radio frequencies, then you might understand a little better, right? So let's look at it. We want to build them out at each one, right? But how do they build in radio frequency versus how we see our Tesla coil? Well, Well, let's entertain that for a minute. Let's just get rid of this. When I first put in my Tesla coil ring, you say, well, at one radio frequency it pings, right? So right there on that line. Say, okay, well, at the second one, we'll ping it again, ping it again, and ping it again. So what am I essentially saying? Every time I run across one of these, I get another radio frequency, right? That's where it rings the most before it goes back to the other side. Say, okay, but didn't you tell us before first that these were octaves? Well, yeah, I did. You go, so you're saying it's a radio frequency and an octave? Well, yes, it is. You see, now we're going into a little better understanding of what we're actually dealing with. An octave is 2 over 1. Okay? So it's building out the same way your octaves are, but I'm also building out every time in the radio frequency method. Every time you find resonance, it's at one of these points. You go, well, hold on, what does that also mean? Oh, well, let's travel down the rabbit hole with Nathan today. What if I just did this? Yeah, was that a snail? What if I told you it's the golden ratio? If I took and built this thing out, I put a line across it, what am I showing you? No, you go, well, you're showing me an octave and you're showing me a radio frequency at distance, right? Well, I showed you the same thing a minute ago. Right? Isn't this the same thing right here? That's my Tesla coil ring. What's the trouble people have with this? Well, let me draw it the proper way then. Just say, well, that's pretty interesting, isn't it? You're drawing a tornado. You're saying that it's a Tesla coil ring. You're also telling me it's a golden ratio. You're also telling me it builds out in frequency. You're also telling me it builds out in an octave. Yeah, I am. This is how it's working. This is why we look at everything together when we build it and not as separate entities, because you get lost. These are all the same thing. Put it together very easily. You go, okay, what do I know about this that you may not? Now, this whole thing is positive here. But if I drew it in this, and I said it's negative. You said, well, hold on. You're still talking about your Tesla coil, right? Yeah. They're both there. You don't realize it, but they're both there. Okay. Let's take a look. You see, I take my Tesla coil here. And I tell you that I'm building out the winding. Probably do this in red. Here. Okay, well, that's pretty familiar, but that's just a secondary coil, right? Well, I'm telling you that the same frequencies match up right inside here. And that when I tap the outside here, I get a positive field. We know that to be hot. There's no question about it. That's what it is. Here's where you don't understand it as much, and hopefully some of you are catching on to this. So I put the rod down the center, I'm capturing the negative here, and that right there is cold. Now, is it really super cold, like, man, I'm freezing in the winter? No. It's the room temperature. Okay? And slightly below it. That's it. That's all that I'm telling you. It's cold. It's negative. It's cold. Okay. Now, you go, now we're starting to understand the Tesla coil a little better. There's positive, there's negative, there's hot, there's cold, there's rings, there's octaves. Man, this thing's got a lot of stuff in it. Yeah, I'm sure you just thought it was a sparkler. Let's go a little more in depth. Tesla called this stuff radiant energy, and there's a very good reason for that. Now, here's something that you may not realize, but it does happen. If I took that frequency and I went to the megahertz, okay, what happens? Well, I start to get into a different type of energy, don't I? I'm going to create a microwave energy. Okay. Why? Well, you don't realize it yet. So let me explain it. This is the magnetron inside your microwave. For every distance from this point to this point, and they are consistent, I get a frequency. The same frequency, and they look just like that. If I drew it a lot better, you'd see it really clean. Every one of them is created a frequency. You go, okay, well, we pretty much know that, right? You go, okay, we have this little shape here. It goes around like this to every one. And then we tap. This right here, and it comes out to our microwave, right? You go, well, yeah, That's pretty simple. So we got basically the same frequency running around and around and around, repeating itself. It comes out into our microwave, and you go, okay, but it has to happen in the megahertz or higher, right? You go, so what is your understanding to a Tesla coil of this then? You see, when I tap the negative, I'm tapping right there. I'm not tapping this. That's my positive. Tapping negative. You see, this is why people also do not understand anti-gravity. This right here, if you don't tap that, right now, grab your lunch, get out the door, and go somewhere else, because you don't have it. You just don't have it. This right here is essential for it. So what are we doing in our Tesla coil? Again, this is our magnetron. Okay? Simply tapping the inside of it, just like I'm tapping it here. I'm getting kilohertz here, megahertz here. You're specifically setting one frequency in your magnetron. This right here is pulling off a golden ratio frequency and how it works. Isn't that interesting? We're not necessarily dealing with different things here. We're dealing with the amplitude of them. We're not dealing with the different energy. Step it up, step it down, however you want to see it. So what does that mean? That basically, when we convert anything that has to do with your Tesla coil, if we understand the type of energy we're working in, then we can understand how to transfer this energy. You see, it's all pretty much relative. If you didn't build this out, and if I wasn't telling you this, you probably wouldn't understand it. You see, this right here was a shortcut to this, and I could tell you why. Alexi built out this device. And you say, okay, that's your gravity flyer, right? What is he doing? Well, this is your magnetron. You go, okay, I got magnetic on top and bottom, right? And because of that, I get a directional flow. Well, he did the same thing. Created a directional flow. He created magnetism in a very low level. He then took this and tapped right here. Right in the part that you guys will refuse to understand. He took the negative right out of it and he placed it here on this thing here. Okay, well, what's the rest of the device then, smart guy? If I took the piezo buzzer here and I simply found this, and I wanted this, take my piezo buzzer, which is on a Joule Thief circuit, and I'm amplifying this here. That's what I want. I want this right here, in this right here. I'm looking to amplify it right there. I'm going to set my saturation rate at this right there consistently. This right here is the same as this right here. Now when I push the button right here, I'm going to drop that in there and amplify it. And it doubles like a Joule Thief. Massive saturation all at once. They're tapping the negative in order to do it. What does that also mean? Here's the thing that drives me nuts. People don't understand this. Frequency produces energy. I tried to show this in my Tesla coils. When I set one Tesla coil here, and I have a second one here, I'm getting plasma out of this one, but only this one has a primary coil to it, and this one's just a winding. I have no physical contact with power, yet I am getting a bipolar Tesla coil out of it. I have a ring going in both sides, and I'm getting energy out of both. You see, this is why people don't understand the negative energy. It's a flip. It cannot be static. It has to be a flip. We understand this in our magnetron itself. The inside of that power is the reverse field of the outside of that power. We use the outside of that power in order to cook our food. We cook burritos with it. I use the negative energy of the inside to light my burritos up at 3 feet away with the energy. It's a flip. It's the inverse of it. This is also why people don't understand 0-point energy. They cannot account for the room that they're standing in. They don't get it. Tesla told you there was a sea of energy. That means energy is all around you. It's how much of that energy you're pulling into your device. That's 0 point. A lot of people need to understand this. So, what am I actually doing with the Gravity Flyer? If I told you this is the Earth, right? Told you I got water, right? This is the atmosphere we live in right here. Okay, that's us. What do you not realize? I have water. You go, well, hold on, there's not a lot of it. Okay. This out here is space. I still have water. I have air. Okay? You go, so what am I actually doing? In Alexi's red light test, he showed it to you. If I created a bubble and I remove the water from there, it comes off as steam. And it looks like he's smoking. No, he just eliminated the water from the energy bubble that he created that people refuse to see because they don't know how the fields work. So, what happens then? It's all about buoyancy, isn't it? I'm just going to move that bubble up or down. That's it. That is the most simplified version that I can give you of the entire process of how that machine works. What's the problem? Every time I talk about it and I ask somebody about the fields, they have no clue what I'm talking about. They just don't get it. They've never created it. Because you've never created it, you don't understand it. You see, I get the same thing when it comes down to the rod and the Tesla coil. Because you've never done it, you quantify it as the outside of the Tesla coil. You don't understand it. I can ask you 1 or 2 questions and I know you don't have it. As soon as I sit there and tell you anything about the field and I ask you about it, I just take a couple questions and I know you don't have it. You see, every time you create this field bubble, it creates energy. One holds in the other, or if you flip it, it pushes the other away. Nobody understands it. I know you don't have it. You know, we all laugh at Jack Staffardi when he tells you you don't have it. Why? You don't talk about the negative energy. As soon as you don't talk about it, you don't have it. He already knows it. You're just wasting your breath. You're out there talking about the positive, the outside of this coil, and he can care less what the rest you got to say. He doesn't care about the math that you talk about. He doesn't care about any of it because you don't have it. We learned a long time ago. Why? Why did they learn this a long time ago? Oh, we love to do this. And Nathan, why are you drawing flowers? What is that? Well, it's a very bad drawing, I can tell you that. Flower of life, seed of life. Anybody understand that one? It is also the original structure of the magnetron. You see, back in the 30s, the Germans were out there learning from the occult. They went to every single thing and they learned everything that was there. They understood the carvings on the wall were representations of formulas on how to build something. They understand frequency. They put it all together. We got this information from them. And in the 50s, we started to put it out as a microwave oven. But it started right there. When you look up an old magnetron, that's what you're going to find. It may look a little more complicated with a few more of these. I won't deny that. But it's the same thing. They knew this technology. They knew to tap the center of it. Every time you see it, always has that in the center of it. We look at Alexi's device and we start to look at why that man would build it like that. He flipped it the other side. "180 degrees out of phase." They knew it. They built the magnetron based on this kind of technology. The answer was out there right in front of you the whole time. The problem is you got so many words to quantify something that you forget what you're even doing. Energy works and flows in a certain way by frequency vibration, just like Tesla told you. That's the way we need to understand it. He already told you how to do radiant energy. He told you about all of it. Tesla has a simple patent. There's a plate, there's a load, there's your ground, there's your Tesla coil, Tesla told you. Directed energy. They use it for crowd control. We have it. We've always had it. We don't realize that they're all pretty much the same thing. It just depends how you manipulate it. All of these things, all of them, starts out with a simple understanding. Can you take that Tesla coil and understand what it really is? Or do you just think it's a sparkler? Every time I talk to somebody about this, they have no idea what I'm talking about. And I know right away they didn't create it. They didn't create anything to do with it. A Tesla coil, when going from one Tesla coil to the next, you cannot run them at a super high amount of energy because they're producing their own energy, and they give you a field that bounces back onto you and into the entire room. Everything in your room that's metal will burn you. When you start messing with Tesla coils and creating energy in secondary coils only, everything in your room that's metal will burn you. There is so much more energy in that frequency than ever could be put in by that power supply. This is why people do not understand Alexei when he built this machine. He has like 100 times more power than you ever will with your hot energy because he has the right frequency in it. He's amplifying that frequency. I'm sorry that you don't understand some of this for the people out there who keep telling me all this stuff. But that's the way it works. You see, I'll show you this right here. When you create 0 point in a coil, you have a hole right here in your coil, okay? Let me draw this a better way, because I don't think people really understand it. Right here, build your coil. Man, I wish I could draw better. I'm not just taking the energy that I'm running through the windings here. Okay? That's one part of it. I also have this thing set up in a toroid. So I'm getting an energy that spins already. This alone is not 0 point. What is? Every time the energy from the room goes in, comes out, energy stays and sticks here. If I say these are my electrons, I'm adding electrons to it every time it comes through there. What's the thing that's going on with this then? Well, you see, it continues to add every time it goes through it. Every time it goes through it, it adds more electrons to it. What's going on with the temperature? You see, the temperature drop is not something that you could just go over here and take and make it super cold in the center. All right? I have to get that energy from this. That's creating the cold because it's creating a vacuum. Every time it goes through the vacuum, it's taking the temperature in the room and I'm lowering it in here. Out here, it's room temperature. You say, well then, if it's lower here and it's room temperature here, I have a temperature differential between the two. Well, yes, you do. Because you created a vacuum going down the center, therefore your temperature in the room is going to reduce in the center because of the vacuum you created. That's 0 point. This point right here, this null zone is your 0 point. Your temperature differential creates your 0 point. It's not just about the energy you put into the coil. It's how much energy you pick up. If you say these are all electrons, by the time I'm done with this, I can keep drawing this all day, and I'm going to keep creating these, right? Also going to create this. This right here, oh man, I love this one. That's your time. That's it. Every time I build one field versus the other field that nobody seems to understand, It's time. That's all there is to it. If you create 0 point, you create gravity, you create time, dilation. That's pretty simple, right? I mean, I could say it in fancy terms, or I could just tell you what it is. My concern is, guys, I'm telling you everything of what it is, and people still don't understand because they have to put it in their fancy words. It doesn't have to be fancy, it just has to be right. You can create the energy if you know what you're doing. You see, that's why builders are important when it comes to understanding physics. I'm going to build it. Okay? That's the way it works. You can define it when I'm done. But this is the understanding. It shows up in tests. Guys, I've showed it to you. I have straight out put that cold energy right into it from that Tesla coil. Pulled the wire out. There's no energy going to it. Yet the energy stays in the coil. Why is it doing that? I created a temperature differential inside the coil, inside the entire room, entire thing, in order to create this. Now I created a 0 point field right there, taking in the energy. You know, you get lost in, does your system go over unity? Well, if the energy is all around you, what's over unity? If I match the energy of the universe, maybe that might be over unity. When I accomplish more energy inside of a system and I'm picking up energy from the room itself, is that still over unity to you? Or is it simply picking up more energy that was already there? You can define that. I don't have to because it works. This is simple understanding. We should all start to understand how these principles work. Do not have to define it in fancy terms because it's a waste of my time. I simply need to understand this. I'm going to ring a Tesla coil. I understand what this is. People should understand it as well. I'm going to use this coil in order to do it. That's as simple as it gets. I create both fields in this, the positive and negative side of the field. We do a lot of investigation on this channel, guys. I've created a can to show you how to flip a field. A soda can. Now, it may sound like I'm bitching today. I'm just getting a little frustrated. You know, you try to talk to people and leave them comments on stuff, and they're so out in left field that they don't understand what you're trying to tell them. They think that they have this big understanding of physics. Well, yeah, you got a lot of fancy words. You don't have very many examples of it. I'm showing you examples. When I take a can, take my Tesla coil, I go over here, and I am simply creating a wrap around a soda pop can, right? I create another wrap, which looks like this is a loop, and then I'm going to wrap them together, so I'm going to draw them as one, like this. I take one of the wires here, and the other ones I tap back to the soda can, and I take both wires off here, and I put it into my full bridge rectifier, and then I send two of them off to create DC. What did I know that you didn't know? I knew that as soon as I created the can, I'm creating a resonance chamber. Okay? That's pretty simple. I'm taking the windings. All I have is tape here as an insulator, and I'm putting in direct contact right here with the can. What's going to happen anytime you put windings around an aluminum can that has eddy current in it? It's going to heat up. The heat will go up. When the heat goes up, the volts go down. That's pretty easy understanding, right? The heat goes up, the volts go down. What happens to the amperage? Your amperage goes up. I'm just converting it. I understand how it works, so I am converting it very easily. I went from a giant radiant field down to a field that looks like a DC flyback field because I understood the conversion. Now that I know I'm in DC energy and it's a flyback energy, all I have to do is convert. This right here will heat up even more. What does it do? It gives you more amperage and less volts, but it's a conversion. Now, if this wire matches it in 1/4 of this, okay? One, two, three, four, we're in the 4th octave. I want 1/4 of it, and I want that right here. Now I'm going to pick up extra energy as a multiplier, because now I am matching one of the frequencies in my Tesla coil. Now I can pick up extra energy. That's how Don Smith did it. That's pretty simple, right? You know, I did a video on my channel about forcing resonance, and I really wish people would understand what I was trying to tell them. You see, you can hit the resonance value of your coil, which is at the very top. I was down in the 3rd octave of that coil, but still making the energy go, still creating plasma. How? Because I knew exactly where I was in the field. I knew which octave I was in. That meant that those coils were actually resonating on the secondary coils with no attachments to them at the 3rd octave. I did not build them correctly based on my number 1 coil, or my primary driving coil, I should say. Had I done that, and I did it in further experiments, that they run at the regular frequency of the coil, which means the very top frequency, or the biggest one that you see when I make the frequency right there on the board. Then it would have got optimized. What happens when you optimize it? Everything in your room that is metal will burn you. The energy in the room itself is amplified everywhere. Not just 1 coil, not 2 coil, but everywhere. I can go over my toolbox and it's amplified. I can go over my 3D printer, which is aluminum, and it's still amplified. Every bit of metal in your room will be hot to the touch. There's so much more energy and frequency. I wish people would really understand that. Easy conversion. Edwin Gray, what did he do? He understood what he was doing. He took that field. So I laugh every time I say it. Can you create cavitation in something and create more energy? You see, this is just where the cavitation is. The fields on it go beyond the level of the cavitation. So if this is your cavitation level, the field is going here. If this is my cavitation level, my field is going here. Now, Edwin Gray was able to push everything back and hold it on the outside. Now, all that radiant energy is stuck in here. At any level, you can pull off and get one level of your energy. Now, they did this in what, the Tasikiba experiment as well. They're doing the same thing. At each level, you could pull it off. As long as you create the energy here, it's different. That'd be negative energy. Now, there's two different types. There's radiant energy, which is negative, which is a very, very high level. Okay? Then there's regular energy, which is negative, which, the reason I showed you the entire thing right here with this coil, because this can be created with your MOSFETs running in negative. What does that even mean? It means that there's actually no heat. There's no heat. But you're pulling the negative side. So what are you doing? You're lowering the temperature. You are creating the environment for the 0 point right here to pull it in. Because of the temperature differential, it's going to have a flow. That's fairly simple. That's about as simple as I can make it without putting 100 words in there that just sound like gibberish to normal people. Evan Gray used this in order to amplify the energy because he could pull off of it at any time. Don Smith used it in the frequency that he created. He knew how to create a quarter wave, a third wave, 2/3. He knew how to create those waves. It's all in the frequency he put in there. You get over unity when you can understand that frequency carries energy. You get 0 point when you can understand how to work the room. If you can create the energy in the room to come into your system, you have it. The temperature itself right here has to go down naturally. You see, we force it. When we start hitting it with a whole bunch of other stuff to make it frozen, we're forcing it. You're brute forcing it. You don't want to do that. You're creating the effect, not the cause. The cause is the temperature differential. The effect is it gets cold. Anyway, I hope you guys understand this. Sorry if I seemed irritated, guys. I try so hard to tell people this, and I don't think they even get it. So I hope that you guys do, and hopefully you understand where I'm at. So anyway, I'll just continue on building stuff and see where it goes, but this is the understanding of it. It's fairly simple. It's all on the same technology. You just had to understand exactly what it was trying to tell you. Anyway, have a great day. Thank you. What's up, guys? Hey, sorry I didn't answer a lot of you guys' comments. We're kind of running the video there. So, real quick, there's a lot going on. What's up, Ben?
Hey, how you doing, Nathan?
Doing great, man. Did you understand any of it?
Some of it.
Got some parts, Nathan. Getting there.
I saw some interesting things, but in the long run, I think you're way ahead of me in terms of understanding this stuff.
No, it's funny. It comes down to something simple. It all flows together, and it just depends what frequency you're in and how you can manipulate it. All of these over unity devices work the same. They're not much different from each other. You can add one to the next and the next, man, and you start multiplying the system like crazy. Mm-hmm. They don't understand. I mean, if you get a Tesla coil to light up with nothing attached to it, and you're getting plasma out of it, you're pulling energy, right? Well, that energy is coming because you created a frequency, not because there was a primary coil with volts, amps, DC, AC. It just comes from the frequency. So it drives me nuts when people don't understand that. But you could just amplify your system with it all day. You could put one in each octave that you go into, which is hilarious, and then just amplify the living daylights out of a soda can. I mean, anyway. So what are you up to, Ben?
Not a whole lot. We do have some updates to present with the lumen lamp and all that stuff. But that's going to be in a little bit. I have to prepare a couple of things. We've been doing a lot of testing with the lumen lamp, and I've been using it as a lamp. It's pretty nice. We made a website as well, so I'll share all that the information in a few minutes.
Okay. So I just want to answer some questions here, and I don't know why these things are all big like this. I'm going to have to fix that. Let's see. So change your frequency on cold electricity, you make another coil. I don't know how to say this, but I've been doing this on my channel with all of my stuff. Ben, how do I make cold energy out of the coil?
Wait, what was the question?
Just how do you make cold? How do I usually make cold energy out of my coil? What do I light up my burritos with?
Oh, the Tesla coil.
But where do I put the rod?
Oh, you put it down the center, yeah.
Okay. So you don't have to make another coil, it's right there.
Yeah.
I've been explaining that for the last 30 minutes.
Yeah, so the way that Nathan likes to explain it to me, because I'm stupid, is the Tesla coil was meant to be a pump, not like something that was putting out, but attracting energy. And you can use it as a pump and put the wire down the center and tap into that energy.
Yep. That's right. Just a pump pulls in the energy. Yeah. You don't got to make this overly complicated. I think a lot of people think that I'm talking about something more than I am. I seriously take my Tesla coil, put a rod down the center, and that's about how complicated I get. You know what I mean?
And there's a reason why Wardenclyffe Tower was so big. It was reaching off into the sky to reach the ionosphere to attract, not to, put out like a lot of people are doing with their Tesla coils, but to attract and use that to enhance the pump, I assume.
He put it out in the groundwater. You
see,
this cold energy, it works with crystal, which means any quartz, but it works with oxygen and water.
Yeah, it's a natural capacitor.
That's right. So if you tap into the water level, right, the water table, then it goes everywhere. So
exactly,
as soon as Joe Blow
puts it anywhere,
rod in the water thing to getting his water out of his well, he gets electricity.
And because it's cold electricity, it's not really going to interact with you in the same way. I don't know. I've never actually gotten shocked by it, but I know that you guys have claimed that it feels different. Like it's not normal electricity that you're dealing with. So yeah, and I don't know, but it might not be as dangerous to deal with the cold electricity. I don't want to make any claims like that, but maybe, maybe.
Dude, I tell you, I put it in water and I put my hands in there. No problem at all.
Yeah, see, that's evidence to me. That's evidence to me that it might be safer. So,
matter of fact, I put the light bulb underwater and connect it, and the thing lights up. It's hilarious because you think, oh my God, you got electricity in there. I can see it. The light bulb's on. And you go, that doesn't hurt me at all.
Well, when you think about that, and then you think about, well, how do they make pools, underwater lighting for pools? They're using hot electricity, hot wires under there. You know what I mean? So it's like you have a solution.
They use a real low level of it so that it would structure the water more than hurt you. Because they're in like 12 volts. They're nothing in that. They're not attached to the main source there.
So okay, so
I wouldn't like it.
But I wouldn't. Yeah, it's just the idea of having that hot wire anywhere close to your pool. It makes me uncomfortable.
It makes me uncomfortable as well. So when I do a conversion to a can, so let me just explain this, guys, so we understand it. If I'm taking a radiant field, which is basically the cold end of the Tesla coil, the inside of it, put the rod to the can. I'm not just simply wrapping it. Okay, I can wrap a thing around, but then if I put a secondary in the center of that wrap, I can get the hot energy because the wires are so close together that they build up heat in between them. But when you're going with the big coil, you go, well, now I need to create some heat. So I need the heat to go into the can itself. I need that can to get hot. So what I do is I take a wind from a wire, which is basically take a wire, bend it in half. Okay, got to do that part. Got to have that bend. So now you took your wire, now it's half the length. You take it and you wrap it, just like that. What is it doing? That's creating heat. It's usually known as an amp circuit inside there, or like an amperage, however you want to say it, creates amps. I run that one side into the can. The other side goes to the full bridge. Now, the side that went into the can also goes to the full bridge. What I'm doing is I'm forcing the heat all inside that can. In that little resonance chamber, I'm forcing the heat. Now it has to get hot. No matter what I do, I'm forcing that thing to get hot. When you get it hot, you get amps. It's as simple as it gets, and we're going into a full bridge rectifier. Guys, these parts are like junk parts that I pick up from my garage, and I literally wrap them together because it's the principle that's more important than any kind of material you put into it. I don't care about exotic materials. I just want the principle to work. Anyway, I had to explain that because I get a lot of questions about that. Or if I'm out of resonance on my Tesla coils, I get the energy to work in different octaves. So at different ones, you can resonate them and find out where your frequency is on other coils around you. So I did that one of my experiments because I wanted to light it up in a different octave. So I just said, you know what? Let's put the wrong one in there. And then Ian's cap bank is absolutely amazing, by the way, to do this in, because now I can control every single one that I want to be in. And I can flow from one to the next, to the next, to the next, and keep going until I get to the maximum level. And then, all kidding aside, my whole room starts to get energy in it. And it's hot. You go over, touch them, I keep getting burned. So I have to turn that sucker down to 12 volts or below. I would like to turn it down to about 5 volts, to be honest with you, which may mean putting my Slayer exciter in there instead of my ZVS, because I can only go to 10 volts in the ZVS before it dies. So that's kind of a big one. I wanted to show you guys real quick a video. And I want you guys to understand this video because it shows you the energy staying in there. Okay, right here. Now watch, I'll put that rod down the center of my testicle, right? You see the light on. Now pull it out and show it to you. The light's still on for a while. See, that light stays on.
Yeah, there's a little latency there. It's like it's not sure if it wants to diminish.
Yeah. So what it's doing, guys, is it's retaining the energy because the energy is flowing through it, making it a different temperature. And it won't go back off until the temperature differential is changed. You're retaining energy because you let it flow into there. That's what I'm trying to tell people. It's a little bit different than what you think. Most people over here would take liquid nitrogen and go, I'm going to take the center of this sucker, I'm going to make it ice cubes. It's just the wrong way to go. You're not making the energy by making it ice cubes. That's the effect. You want the cause. You want that room to pull the energy in. It needs to flow through that coil so that it makes it colder. Colder is just the effect. The energy staying in it and attaching more electrons to the wires is what you want. That's the biggest difference there. That's a complete different understanding than most people would understand that at. You can't watch. Okay, well, Sorry, man. I know what the 0 point is, and I know where it is, and I know the energy's got to go through there to get to that. So, got to open it up somehow. It's not a field out of nowhere. All right, man. So, Ben, you still there?
Yeah. So I was gonna say, if you show it, they will come. So you had a video. Let's fire it up and let's see what you got.
Yeah, I was just showing it.
Oh.
Sorry. Yeah, Ben, there's a lot to this, man. And I've got like 50 videos on this. I guess it'd be hard to keep track, huh?
Yeah, it is hard when you have so many videos. It's hard to organize. You got to tag them the best you can.
Yeah. So somebody was talking about MWO, I think it is. Is that
NWO?
Yeah, it was somewhere in the comments. It's two basic how do I say this? Two windings of copper, right? They sit attached to a Tesla coil and they shoot towards each other. Okay. And the person sits in there. But there's a better way to do that. So, and I'll just show you this video and I'll kind of let you kind of read between the lines because I'm going to ground out the bad parts and give you the best part. So let me share that with everybody. And I know it doesn't seem like it, but you just got to understand what it is. So my Tesla coil is hooked to the rod in the center. It goes right into the mud, right? Now, it lights it up at distance everywhere, right? What happens when you touch it? You see the mud grounds out the volts and amps. You're left with just the frequency. In that MWO device, that's what you're looking for. This is 10 times more efficient. Multiple wave oscillator. There you go. Yeah, there's so much difference in this stuff, guys. If you really want to create over unity, you have to understand amplifying of coils. You have to understand transfer of heat, and you have to understand that there's two sides of energy. There's a hot side and a cold side. Cold side simply means room temperature and below, and the energy is more efficient. Think about it. If I removed hysteresis from the whole situation, if I just simply remove the heat, I now can get closer to 100% efficiency in anything that I do. I don't have any loss. I removed the loss. I removed the hot part. Now, as I take in more cold because the environment allows it to, now I build more energy. That's pretty simple. You can't build it with hot energy because you're constantly burning it off and wasting it. It will not build correctly. You'll fail every time. You have to build it in cold so you can get the energy. Then you can convert when you're ready to use it. So it'll keep building until you convert it. And you can turn the conversion on and off whenever you want. That's what the whole thing with Edwin Gray was. He literally took that conversion and turned it on and off at will. So his stuff didn't heat up all the time with amps. It went cold, then hot when you needed it. Cold, hot when you needed it. But it kept pulling back in the energy. Okay, much better system. I really like that one. Ben.
Yes.
You building anything into that coil to get it any colder?
Well, I haven't really been able to test it since it's been so cold out, already. It's kind of hard to gauge at the moment without like the thermal gun. I had a nice like a laser thermometer. I think it was a nice laser thermometer from my previous employer that I used to use, but I don't have that anymore, so I'm gonna have to order another one.
Okay. Gotcha. Have you ever, I don't like these big captions. Have you ever
what's going on with that? It's like somebody put it on grandpa mode.
Yeah, dude. Oh, it's good, dude. Yeah.
Somebody's pranking us. You know, like when somebody buys you one of those joke remotes
Oh yeah.
from Spencer's, those huge ones.
Somebody bought me the clapper for Christmas. Yeah. I actually could use one of those in my experiments. I'd be clapping all the time to off lights.
I would love that. I would love that as well. So that sounds fun.
I've ever put a microwave down the center of the road and coal. No, I haven't.
A microwave down the set. How big is your
No, I have not done that.
There must be one big coil.
Well, probably just talking about the frequency itself. I
Oh.
haven't built any Tesla coils at all that are in the microwave range. I know some people that have. They put them in the terahertz range. It's all about the size of the coil. You make them real small, and then the frequency shoots to the roof. You make them real big, you know what I mean? And then the frequency comes down. So if you show me like a 3-foot coil that has a 4-inch diameter, I know that you're trying to hit close to 100 kilohertz or under with that coil. Alexei did that. I always wondered from his experiments, why would you bring down the frequency? What were you looking for? Yeah. And I think he was looking to get down on the hertz or get closer to it because he was in too high of an octave.
Yeah, he was in the kilohertz. He was getting down to the hertz, more of like the Schumann resonance, maybe. I don't know.
Oh, you couldn't get that
too
far.
Low? Yeah, that's too low.
No, I don't think you got that far.
Baby? But I guess the idea is to try to get as low as possible, maybe? I don't know.
Yeah.
Interesting.
Well, because you hit the numbers better, right? So if you create a quarter wave to a Tesla coil, you know what I mean, for the full thing, and you're not getting all the energy out of it. You're getting 1/4 of the energy, right? So if he's trying to amplify energy, you want to be as low as you possibly can. You don't want to be as high as you can. You want to get that frequency a little lower so when it hits harder. I don't know why we want, you know what I mean, megahertz and all that stuff in a cold energy system. In a hot energy system, by all means, you have to have it. Not on the other side of it. It goes the opposite direction.
Yeah, there's a yin to that yang.
Yeah. A lot of people don't realize this is backwards.
But I mean, it makes sense because the universe is balanced. You know, it's all about balance.
Yeah. The hot cold room thing, man, I try to tell that to people. I really do. And maybe I just don't say it the way they want me to say it. You know what I mean? I don't see electrons, but I try to put them in the presentation because I know a lot of people do, and that's how they see it. When I build it, it just builds out like fields and frequency. That I can pick those things up and see them. So I always talk about them. But if you want to say electron flow, go ahead. I'm not against it. It's not what you see when you're building. So it's kind of hard for me to, you know what I mean? Because I'm just talking about how I build things. So anyway, yeah, it was kind of cool, man. You take that coil, you bring it down in temperature by the flow of it. Man, you know, Gerald does that too. He once he got that heat and cold thing worked out, man, he could just change that thing everywhere, which is just an amazing sight because he just changed it by how he puts in the wires, which wire he wants to connect, and then he changes it. It's kind of cool.
Yeah, I'd like to learn more about his setup. Michelle and I were discussing we want to try to replicate some of his setup and implement it with ours. So that would be cool to do. I know he's got some questions. So next time Gerald hops on, I'm gonna make a list for Michelle and ask him some important questions to maybe integrate his research into ours.
Gotcha. Yeah. Well, everybody wants Gerald's stuff. I can tell you right now, if you put it out,
I gotta get in line.
Yeah, I'll tell you that right now. There'd be a giant line for that one. And if you weren't in line, you're in trouble. Yeah.
That's funny. Well, you know, it's worth the wait. It's definitely worth the wait.
Yeah. So, have I been on a show with Bernie lately? No, I haven't. So I don't mind being on a stream with Bernie. It'd be kind of cool. He's a really cool guy. So no issues there. Just haven't done it in a while. So with black spots in the fluorescent tubes, it's just not enough energy to excite the gas. I don't know if it's a wave. I don't know if it's a pressure difference. I just know that there's not enough energy to excite the gas. Let's see. Sorry, I'm trying to read the comments, Ben, as we're here.
No, you're good. I'm going through a couple of documents too, yeah. Oh, that's right. Because I was planning on doing a live stream about the new laws of thermodynamics, regarding according to Walter Russell. So I do have a live stream planned for that, a whole lecture that kind of breaks down his new laws of thermodynamics, or according to him, what's going on. To kind of help, simplify and rectify some of those questions that people have.
Well, send me that PDF if you got it. I'd like to read it.
Oh, my presentation file? Yeah, I can send it to you.
Yeah, Walter Russell's awesome. Anything he's got, man, would be cool.
Yeah, I got the presentation file that I put together, and I think I have a couple of resources, some that I used and some that I didn't. So I'll email that to you in a little bit. And if I don't remember, please remind me, because sometimes I get overwhelmed and I do forget.
Yeah, not a problem, Ben. That I can remind you of. Yeah, by the way, you don't need a Tesla coil to create the ether field. You basically need to understand that it has to get colder and you can't have heat in your system.
There was some wild theories that Malcolm Bendel was talking about regarding just being able to manipulate the aether with hand gestures, and utilizing different hand gestures and motions in specific ways, and utilizing your body. So I don't know. That's interesting to think about. So just movements and hand gestures could maybe manipulate the aether.
Well, I don't say this. If you ever work with a Tesla coil, that's pretty easy to understand. As soon as you come near it, you change the frequency in the coil.
Yeah.
That's why your double slit, I could say that wrong, double slit experiment. As soon as you turn on a camera in the room, as soon as you stand in the room, as soon as you go in there, you're adding energy inside the room. You're creating a field that wasn't there before when you tuned it.
Well, the body is basically made up of a bunch of tiny coils. So
well, your body's heat.
Spirals.
It's capacity.
It's heat too. Yeah. So, I mean, it's all the elements are there.
Probably a little more heat when I walk in the room than you, because I got a bigger body, but it's still there. I mean, you're not changing the world here. I mean, you're not accounting for everything in the room.
Stefang said, Russell says we can transmutate elements with just our bodies. So that's interesting. Yeah, I mean, I don't know a lot about his work. I know I did the preliminary research just for his breakdown of the new laws of thermodynamics. But outside of that, like, I really don't know that much about the man. So it would be interesting to do like maybe an episode devoted to Walter Russell. In his work, because he worked apparently he was working right under Tesla.
Then he would probably know what's going on. That's probably why he thinks that way. That would make a lot of sense.
Yeah.
So what was I going to say? Walter Russell, I was thinking somebody else right there. Sorry, go ahead.
Do you think Einstein was actually smart? Yeah, I think he was a smart guy. I don't think he was stupid. It's just when you disclude, like in terms of Einstein, my opinion about the man is when you discount the luminiferous, I can never say that word. Luminifer, the aether. I'm just gonna skip it for now. When you exclude the aether from your equations, then you really have nothing left to work with, and you're kind of like left filling in the blanks there with hypotheticals and variables that you have to make up and pull out of your ass. So
Yeah, his idea of, how do I want to say this? Special law of relativity is right. He's
yeah,
100%
no,
right.
he's not wrong, but it's like it's not complete. There's still a part missing that we have to account for that quantum physics isn't doing, and that's the aether. And I think that stems from the Michelson-Morel experiment. Everybody's like, oh, that failed, so no, there's no such thing as the aether. But they did the experiment wrong, as we now know. And even if they didn't do it wrong, it's just one type of experiment they could have run. There were different theories of the aether, and none of them, said you had to, none of them, like just testing one isn't proof that all the theories are wrong, basically. So it's kind of like a asinine way to do research.
Well, yeah, but they couldn't prove the ether one way or the other. You know what I mean? They knew there was an energy source there. They didn't understand how it was built, so they came up with alternative ideas. I think the ether should have won out. I'm on that side of it, but I understand why they did it. And then,
so it's almost like they could see the effects of it, but they couldn't actually, see it, kind of like dark energy.
Yeah, they see the effects. They can't quantify it. So then they come up with different things, and because they don't want to understand the other side of it, they change things, and it's not much. I mean, some of their stuff is really, really close, but it just needs that little bit more. And they do the math, and it's right there, and then they write it off as something different than it should be, and it's really just accepting it's there. That's it. I mean, what I think the biggest failure in it is not leaving the door open for other ideas. As soon as you say ether, they shut the door and walk away, and they go, we're out of here. I think that's the biggest problem with it. It's like you should have left the door open. Now we're dangling strings, and you know what I mean? Making up different dimensions, and you know what I mean? We're all thinking we're in the multiverse and stuff. Now that science goes, and we're not in that at all. You know what I mean? We should have been looking at time dilation. Why are there ghostly figures sitting around that everybody talks about? Well, could it just be time dilation going on? The energy is just there and hasn't dissipated. I mean, who knows, man? But
I like to tell people, like, regarding the speed of light, some people say that Einstein was wrong because the speed of light isn't constant. It's variable. So he was wrong on that. But the fact is, how many people can actually test that theory? How many people actually have the equipment to test the theory if light is variable rather than constant? Not a lot of people. So we just have to go off the words of the academics.
You can create light with electricity, and based on the amount of amperage you put into that field, the light color will change, and it'll change the speed of that light.
Yeah, but how many people actually know that? I didn't know that.
I don't.
Like that's not common knowledge. I don't think they would teach that in school.
Because they don't sit around the garage and play with high voltage. They wouldn't know.
But that is awesome. We should do that experiment. That is really cool.
Yeah,
I'm willing to do that.
It changes the frequency when you put in the amps. It changes the speed of the light. Changes the color of the light. Changes all of it. And you just have to observe it and watch it, and then you go, how do I manipulate this into the right experiment that shows it off so people can understand it? It's not hard. We've been doing it for a while, man. I take my voltage, and it comes out white sometimes purple. I can make that sucker pink, man, or I can make it white hot. It all depends on the amount of magnetism, or the amount of amperage that's in that field.
Yeah. Yeah, I guess my main point is that most people just don't have the equipment or the facilities to contest some of these mainstream theories. You know, they just have to, go off of basically people's words, and their reputations.
Well, they should just go off the testing, whatever the testing shows. Like, look,
Yeah.
if you had an alternate theory of an ether, right? I'm willing to listen. All you have to do is show me the experiment.
Exactly. Yeah. Show the experiment. Don't just show them some numbers, on a table or whatever, and explain what the numbers mean. And like you actually have to have an experiment to go with your theory at this point, because it's just different when you experiment with the stuff. It's not what you expect. It's not something you can anticipate. Every time I go and expect my system that I'm monitoring to behave that it's the way it's supposed to, and I do something slightly different, I'm like, oh, this should change it in this way. It doesn't, it acts completely different, and it's weird. But it's
Go ahead.
I was just gonna say it's weird, but in a good way.
Like when you disconnected the negative on your coil.
Yes, that was so cool. It was an accidental discovery. Like the discovery of penicillin.
Yeah, well, you got happy accidents. Was that painter with the big afro said the same thing? I don't remember his name,
Ross.
but but there you go, Bob Ross. You just got happy accident.
Yeah, I did. I had a happy accident. I was tired or something. I must have disconnected the wire in accident and fell asleep for a few hours. Then I went to monitor it, and I'm like, what? This didn't go down like at all in voltage. Like I was at least seeing a 0.01 volt per hour drop on the battery up until that point, and it didn't go down at all after like 3+ hours. I'm like, what the F?
I have a Discord, but I don't ever use it. Sorry, I was answering a question.
Mm-hmm.
I guess we should ahead of time set up some kind of Discord thing, Ben, because I know that you go on there.
I do when requested. I don't like to keep it up because it's annoying and it takes a lot of resources from my computer. But I do go up on there when requested. I do have a Discord server hooked up if you guys want to use that. I don't know if you want to make your own or use that, but it's up there. I just, it's empty. It's a ghost town. There's nobody there.
I'll be honest with you. In a lot of this stuff, what we're going to find out is we're going to build it and it's going to work one way, right? And then somebody's going to find out how to amplify it. And then it's going to work much differently than when you originally started. Because that's the way experiments go, right?
Yeah.
You build, somebody finds a different way and builds a little better than you or whatever. And then you have to follow that. And that's what I mean by the open mind. Guys, I do the testing so that people could tell me what they think about it. You know what I mean? And then I change the testing. There's a lot of tests that I've done based on people saying, hey, if you do this, it does that. If you do this, it does that. Like I'm working on the test right now with my Tesla coils where I'm taking the second coil that has nothing attached to it. I'm connecting a capacitor to it and then seeing if I can't pull it out without changing the frequency. It'll change the frequency as soon as the capacitor goes in. But then after that, can I get it to stop changing the frequency of my coil? See, once I could do that, then I could just start pulling them out wirelessly and take the energy I want from them. So I'm working on that one right there. Somebody had suggested that, and I've been trying to make that work. So I think that's kind of cool. Let's see what we got going on here. Anyway, yeah, I'm not against the idea of the Discord, guys. It just I don't go on it very often, and I don't understand much about it yet because I've been kind of busy. So that would be fine if Ben wanted to set that up. I would let everybody know ahead of time, and I would definitely do that.
Sure. Yeah, I'll set something up on my Discord server and send out the links. But give me like 5 minutes. I'm gonna take a quick break, and then when I come back, if you want, I can start my quick update. Just have a couple of updates to go over.
Not into the different dimension stuff, so I'm not either. That's kind of, it's fun to talk about, but I'm not into it. No, I like the experiments, and then the people quantify it. I love to hear what they say about it, because then there's a lot of words I have to look up. I'll be honest with you, man. But just to know how it flows, and then, you know what I mean, they extrapolate from that what's going on. I think that's awesome. I really do. You know, it's not an area that I'm going to go to school for 5 or 6 years for, but I'll definitely do all the experiments and have the fun part of it. You know what I mean? The part that blows something up once in a while, that's my end of it. But yeah, I love to hear everything else beyond that. I think that's cool. So yeah, a lot of the stuff, guys, I'm commenting on because I've created it. If I haven't created it, I can't really comment on it. So if I created the energy where you could see it holding in there like a capacitance, then I'm going to tell you about it. If I did the frequency from one coil to the next, I'm going to tell you about it. I'm going to tell you what I'm learning from it, how I'm seeing it, things like that. I don't know that I can go into a field where I show you something, but I have no idea what it is. I think that would be disingenuous of me to do that. You know what I mean? Because I don't study physics in that way. So that would be wrong of me to say. But for what I do, it's all experimental, you know, stuff. And then somebody says, okay, well, it's this, this, and this. I go, okay, that's fine. I'm all right with that. You know what I mean? Just tell me what you think. But other than that, it's all about building something, and then, hey, is it this? Is it that? What is it doing? Can we amplify this? Can we move this over here? I can't show every test that I do, but I can tell you there's about 200 tests to every one that works. So there's a lot that goes into it. I did want to share something with everybody here. They'd probably like to see it. When I was talking about Tesla on the whiteboard there, I was referencing this right here. And it's directed energy from Tesla. So it's pretty simple. The Tesla coil itself, if you put it in one direction like this on its side, it does have directed energy. And I've done the experiment when I've taken the coil right there and ran it into a secondary coil with no windings on it, and it has produced directed energy at it. I think it's fascinating. I really didn't understand this till I read this and see why it was going on, but it does it. You're creating directed energy. So if you use a bipolar Tesla coil in this type of experiment and put the number one coil in the center, then it won't produce the directed energy. It has to be to one side or the other. So that's pretty interesting. Hopefully, if you wanted this, you guys could screenshot it and take a good read on it. But I just thought it was really, really interesting. It explains quite a bit. Anyway, kind of picture that the testicle has a null zone halfway through. It does on the bipolar testicle. It has a null zone. That's why energy comes out both ways. On the one that they showed, it was just a regular one. You get it 100%. I could tell so many smart people out there. I wanted to share to see, and you're the only one. Yeah, well, yeah. So directed energy. You know, there's ways to amplify that, by the way. I mean, you're doing with the Casimir effect. If you put the rod in the center of that, you'll not only get directed energy, you'll get a little bonus in there. I'll leave that to people out there who build it. But hopefully you understand what I mean by that. Ben, you ready?
Oh, yeah. So we
All
have
right.
a couple of quick updates. Not going to take up too much of your time here.
No,
Let me get situated with the tabs. I'm going to present. All right. Can you present that, Nathan, for me? Oh, that's the wrong. Sorry, that's the wrong one. Sorry, I have the wrong one up here. All right, so let's bring this up now. It's the right one. All right, so that's the right one. If you want to bring that one up for me. Sorry about that. So we have some quick updates. So welcome to the presentation on the latest research and developments surrounding the Lumen lamp and Lightning Thief circuits. This exploration focuses on the new configurations, potential efficiency enhancements, and experimental observations that bring us closer to understanding these unique electrical phenomena. So some really interesting observations, and we'll get into that in a minute. So we have a list of all the possible configurations for the device. A couple of them untested and just theorized, but we have the Dual Thief. This is the one that I've been working with. So the Dual Thief setup is utilizing two Lightning Thief circuits operating in tandem, one using the primary device powered by the source and using its own APA coil. The second acts as a wireless pickup device with induced high voltage in the second circuit without being hooked up to the source. So it's being picked up wirelessly. Now we have the new configuration. I'll show you that quick video in a second, demoing the Thruple Thief. So this is a new discovery of mine, a multi-circuit setup integrating two Lightning Thief circuits into a single secondary pickup coil, one to each their own channel, and the primary hooked up to the source. So this is, again, like the Dual Thief, only we're splitting the secondary, the secondary pickup coil channels and putting the start of one channel and the end of the second channel into one device, and vice versa. We're mix matching the channels basically, and they each have their own 2 pins. So it's pretty interesting, and we'll show you the video in a second, but both the devices are exciting the neons. So they're picking up high voltage, both of them, which is very cool. Another configuration that hasn't been tested yet, but it should work, is the Micro Thief. I have to take the time and adjust the resistance with the Lightning Thief device to get the Micro Vortex coil to work with the Lightning Thief. But it should work because I got it to work with the Lumen lamp, and I know the resonance range it should be in. So we know what to aim for. Then there's the Green Thief. So you can pair the Green Machine pulse motor that we're working on with the Lightning Thief, theoretically, to close the energy loop through magnetic rotary energy recycling. Now, again, remember the Green Machine is the pulse motor that we reduced our input wattage by 30 watts. We went down from like 40 something to 12 on the input wattage requirement for the system when we got the neodymium sphere spinning, indicating that we can recycle some of that energy. But the question was, how are we going to utilize it? How are we going to tap into that? This might be the answer, pairing it with the Lightning Thief device to pick up some of that induced energy. And the last configuration is the Lumen Thief. It is untested. This is an untested configuration, but we should be able to get some interesting effects connecting the Lumen lamp for the purposes of redacted. We don't know. We don't know what the purposes of that will be for this moment, but it is interesting to think about the possible configurations and the multiple uses for these devices. Each configuration provides unique advantages based on power output, efficiency, and energy recycling properties. Now, going into the Lumen lamp observations. Now, this is nice. Look at this pink Lumen lamp that Michel made for his wife. It's really nice. It got me inspired. I'm going to print one out for my girlfriend. We got, when we get the 3D printer working again, that's the last part of this update because it did break. But we have some glow-in-the-dark material to work with now, so I'll be printing out some of those. This is his latest creation. I forget the name of the coil, but look at that beautiful coil. It's another swappable option for the lumen lamp. So the purposes of the Lightning Thief are for energy recycling, lighting, and heating applications off the grid. So right now I'm using it as off-the-grid lighting to alleviate some of the electricity bill constraints that I'm having right now. It doesn't, put a foot through the door in the bill, but it does, help take the edge off. When I substitute using that with the 12-volt battery as opposed to using the lighting in this apartment. So yeah, it's just a more efficient lighting option, but it is also important for research and development purposes. The Jewel Thief is a very, very unique, very simple and very versatile system, right? Circuit. So you can utilize it for a lot of different things, but this is what we're using it for in tandem with these coils. We have the pancake swappable coils with the lumen lamp, and then the Abha coils with the Lightning Thief and Green Machine pulse motor. So the light output and halo effect in Michel's coils and the Lightning Thief. So this is an observation made by Michel, and it's inconclusive. So this is up in the air. It hasn't been tested. Excuse me. But he noticed a thin little orange yellow halo coming out from any of the light bulbs being used by the Jewel Thief devices utilizing this back EMF. So this is interesting because I took some pictures of here, I'm going to bring it up. I took some pictures of other light bulbs and I zoomed in and I couldn't see, like I saw maybe like a blurring where the light comes out where it's kind of like a slightly brighter, but not like a distinct yellow orange halo barrier separating the light from the air, which is very, very interesting. Again, inconclusive, just an observation. It could mean nothing, but so here, I'll bring this up. Let's see, share the screen. Okay, so this is a normal light bulb in my kitchen. It's using the same exact light bulb that I got from the dollar store, okay? And you can see it does look at first glance like it has somewhat of a halo, but it's not orange. It's just a blurring of kind of like where the light is very intense at the edge, the barrier, right? It's not really a halo. You don't see any orange or yellow. Let's go on to this next picture. Again, this is the same. It's a little blurry, but you don't really see a distinct orange-yellow barrier halo. But look in the next picture. Not this one. Nope. Where is it? Oh, there we go. Okay, so look in this one. Oh. So you can kind of see somewhat of a halo around. Here it is. See it depending on the background. You can kind of see it. Somewhat of an orange-yellow halo around these light bulbs. And you see them in every photo that I've seen. When you zoom in and you have the correct background and it's not like over whitening it. So I don't know if it's nothing. I don't know if it's just the camera that we're messing with. But it could be nothing. But I did ask ChatGPT about it. And I would like to share what ChatGPT had to say. Give me 1 second to load up the tab. Where'd it go? There we go. All right. So I asked, according to Tesla or other fringe scientists, does using cold electricity for lighting produce unique phenomenon with the light, like maybe a orange yellowish halo? And its response was, there are definitely some interesting claims about cold energy or radiant energy lighting, though much of it remains in the realm of fringe science or anecdotal evidence. According to Tesla's theories and those of other fringe scientists like Edwin Gray or Thomas Moray, cold energy or radiant energy might produce unique phenomena when applied to lighting. Here's what they suggest could happen: unusual light colorations or halos. Some proponents claim that cold energy lighting could emit a unique orange or yellowish halo due to the way the energy interacts with the surrounding medium. This could arise from the excitation of particles in the air or the differences in the energy discharge compared to conventional AC or DC systems. The phenomenon might be similar to how certain plasma discharges produce unexpected colors. So take that with a grain of salt because it is ChatGPT, and we are dealing with LEDs, not actual fluorescent tubes. So there's a difference there. Let's go back to my presentation guide where I have the paradox box. So let me grab that right now. So I'm going to show you. So this is another device that Michelle sent me. I showed it briefly. It's something that we're going to be integrating into our circuits and testing with. And he says it produces some unique phenomenon. We're calling it Project Paradox Box or Paradox in a Box. It is a paradox generator of some sort. The device acts as a inductor or transformer, apparently, depending on the wiring setup. What it is two magnets glued with the north poles touching each other, and then you have the coil wrapped around, a bifilar coil. So if it does what Michelle says it does, it could either act as an agent to amplify our efficiency in our system, or possibly even replace the ABHA coil altogether. So that's pretty cool. Connecting the primary coil for pulsing while using the secondary coil for output transforms it into a functional transformer. So further testing will be required to determine the use of this device. Hey, Mike, how you doing? What's going on? Moving on to the second to final chapter in this presentation is the current challenges with the prototypes. So the Lightning Thief prototype. Oh yes, I forgot to show you the Thruple Thief video. We'll show you the videos in a minute after I go over the challenges of the prototype. So the Lightning Thief prototype has two current challenges, and they're not impossible, but I have to be transparent with you guys because it might delay them getting to you just a little bit. The issues with the open circuit blowing components. So I had a couple of boards blow the power line going to the plus terminal of the power input. The power connection, possibly, maybe I reversed the load output, positive, negative for the open circuit. Maybe that's what happened. But I need to test and verify this because I don't want you to get your device and, go right to the open circuit method and blow the board. So I need to verify the polarity with a multimeter, and I'll do that this week at some point, just to be sure what's going on there and see if we can figure out why those boards are blowing. Again, because I don't want to send them out and have you guys, because the open circuit method is going to be very useful, and you're going to go, use it, and it's going to blow your. No, I don't want that to happen. So we're not going to fry it and find out in one instance. So equipment repair and additional research. So I have a problem with the 3D printer, the Creality CR10. The rotary encoder failed on my device, which is actually quite common from what I understand. It's a very reliable device, but there are a couple of points of failure, as with any engineering system. And it's not an easy. From what I understand, it's not an easy, or it's not a hard repair. It's fairly straightforward. It's just a couple of pins on the board. So I have to pick up a new potentiometer. Here, I'll show you guys that. Technically, it's not a potentiometer. It's a rotary. So this rotary encoder, I have to pick up one and then desolder the one that's broken on the 3D printer board, and then solder this on. And as soon as I get that, that should only take, maybe 30 minutes tops to do that. So then we'll be back in business to printing these new cases that I have with the glow-in-dark material. Let's show the videos before I move on to the conclusion. So I have a couple of quick videos. This might be it. Let me see. Oh, there it is. Yep. So this is the Lightning Thief case that's glow in the dark that I'm going to be sending Nathan. Not this exact one. I'm going to reprint it. It came out slightly off. Presenting the all-new photoluminescent Lightning Thief Prototype Mark 1. Look at that. Oh, baby. Case is a little jacked up, but we're going to print another one. This looks amazing. You can even read it. Lightning Thief Mark 1. So cool. So very cool indeed. I have to back myself up on that one. That is a very cool case. Once we reprint the case, it'll not have that gap there. Obviously, we have a couple more quick videos. Let's see. I'm going to show you guys the Thruple Thief configuration. I think this is this it? This might be it. So this is the new connection setup called the Thruple Thief, where we have one primary
Look at this.
hooked
This
up
is
to
insane.
the primary coil and battery. And the other two are just hooked up to the secondary pickup
There you
coil.
go.
One each has their own channel,
Okay, cool.
but the difference is we're mixing the channels. So on this one, we have the start of channel A and the end of channel B. And on this one, we have the start of channel B and the end of channel A. So very interesting setup here. And as you'll notice, we can tune into each one of these. So let's start by tuning this one. And you should notice it does affect the light very slightly, diminishes very slightly, almost unnoticeable. Oh, and we have a wire that disconnected. That's why this one isn't working. Put that back in. And as you see, both of them are lighting up. You can adjust one and the frequency of the other goes off. Or I'm sorry, you adjust this one and the frequency of this one goes off, I believe. Yep, so see it affects it. This one affects this. So you turn this off completely. And that diminishes a little bit. We can detune that one as well.
So they're all
hum
in
gets
resonance.
Noticeably louder. Each one that you turn on. So
When
this
you're
a little bit
tuned
louder,
in.
slightly louder. This is the more powerful one. So that's interesting. And this is our primary.
Is it the more powerful one, or is my LED just, or my
That's the
neon
Thruple
kind of
Thief
like
setup.
burning out maybe? I don't know.
that's the thruple thief. I might have, let's see if I have one more video to show you guys before I close it out. Oh, yes. Let's do the... Okay, I have 2 more short videos. So I will be sending you a Charmander transistor, the 13009, with your Lightning Thief. But look at this. Something I forgot to mention is it does have a standby mode for this transistor because of the range of its resonance. So you can turn it off, and it's still on. It's just in standby, detuned like the Lightning Thief.
It's very,
You
very
just
low
turn it
bright.
on. So you don't really,
Not
like,
off
I don't even
completely.
need to mess with the switch anymore with this transistor until I replace it.
So the switch actually was broken when the device was sent to me, the lumen lamp. This switch on the left-hand side, it was, you know, these switches are kind of cheap sometimes. They are sent out from the manufacturer. Some of them are broken, quality control, issues or whatever. So I have to go ahead and desolder that. But until I got the desolder braid, what I did was just solder, a line on the back of the board, so it's permanently on. So that was a problem for me because I wanted to test this further. You need need a toggle switch for convenience. I don't want to have to plug it in and out of the wall all the time. So this discovery of just being able to detune it like this was very convenient. Very convenient. And then there's one more quick video. We got the 13009, the Charmander transistor, hooked up now with the 12 volt 1000 milliamp wall adapter, and we're monitoring the current from the light bulb. Okay, and check this out. I don't know if this is relevant at all, but look at this. We're at 8 milliamps. It's probably about almost fully bright. 23 milliamps. So I don't know if it's consuming a lot of milliamps and only using this mount, or if this is actually what it's consuming at the moment. I have to do another test on the source. So I thought that was interesting. Not really sure what all this means. I'll have to run some more tests to see. And there's also different coils that we can swap as well for the lumen lamp. It's basically the same. It's utilizing the closed circuit Joule Thief method. And I think actually you can also utilize the open circuit too. I have to ask Michelle about that. I'm pretty sure it has both methods on here because it has inputs for all 4 for your bifilar. So theoretically it should. And I know the start of channel A and the end of channel B are connected. And that's how you use the open circuit method. So this might be able to utilize both methods. I'll have to confirm that with Michelle. But either way, the lumen lamp is pretty cool, pretty efficient. We're going to be, well, there is a website, and I'll get into that in 1 second. But we also are going to be putting together these kits for people to buy, or if you want to buy it pre-assembled as well. And I'll be making some for the team. So the team has some at some point. So let me load back up the last chapter. So our research into the lumen lamp and Lightning Thief configurations continues to yield fascinating insights into energy efficiency and coil behaviors and unique light emissions. So future experiments will focus on refining the system for efficiency, investigating the halo effect and its potential causes, and testing the center tap configuration for efficiency gains, which is what we're using with this coil. We're using a center tap. So there is a website that Michelle made. I'm going to put in the chat where you can get all this information for the lumen lamp. If you want to build one right now, you have that information on this website right here. If you don't want to wait for the pre-assembled units to be on the market from our Coil Kits Lab Shop, you have the option of going to this website, and all the information is there. The 3D files are there. If you want to print all these components, Michelle has open sourced everything. It's all in the public domain. It cannot be patented. But we are going to be providing you some pre-assembled units if you don't have the means to build them yourself, because I know they're very cool. And a lot of people have reached out to me regarding the lumen lamp. It's made a really nice piece in my lab personally. So with that, thank you for your attention. Let's continue to push the boundaries of free energy research. That's all I got. Appreciate it.
Ben, can you bring up that other coil real quick? That the one I think you said he created for his wife.
That's the pink lumen lamp. You might be referring to the new coil that he made.
New coil. Okay, new coil. There you go.
Yeah, I don't know what it's called, but yeah, I'll bring it up. 1 second. Okay. Let's get rid of this. I'm going to share this on the screen. Look at this. This thing is so cool. Look at that. Here, I'll try to zoom in a little bit.
Yeah, that's really awesome.
I know, right?
Different
I
layering.
forget what it's called. It starts with a D. It's a very long name. Like a Russian name, maybe. But it's a cool configuration. He said it's getting interesting results. So it's going to be awesome to test with one of these coils, and the convenience of being able to swap out your coil here is very cool. I love it. It's, like, it's not just a lamp. It's, it's used, you could use it for research and development too. So, like all the devices that we're putting out.
Ben's going to have a different coil for every month of the year to swap them out.
Oh, that's going to be
cool.
fun. Oh, that's Ian. Ian's got it. The dodecagon. Yes, the dodecagon. That's exactly what it is. Ian comes in and absolutely nails it.
Oh, good thing you said that, because I would have called it something else.
Oh man.
Oh, well, okay. Well, good thing for that. So, no, that's really cool. I think that's amazing. I like that coil.
Mm-hmm. Yeah, it's going to be fun to test with this one.
So he measured out his windings last time, the exact amount of wire.
Yeah.
Did he do that on this one?
Yes, I believe so. I'll confirm it with him in our next discussion, but I believe so. He's been doing that, and I think it's kind of like a good habit to get into. And you've discussed this as well. This is something that Tesla would do. He would measure out the exact weight of the material he would need for the conductor, and make sure everything was from the same pot of metal. It was just very precise and planned out. You want to plan this stuff out 6 months and then spend 6 weeks testing it. Don't spend 6 weeks preparing it and then 6 months trying to get a result, because
I don't think I could do 6 months on either one of them.
That's just the metaphor, or how to say.
Okay. Thank God for that.
Spend more time in preparation is the lesson here.
I should have learned that in my Tesla coils, Ben. I should have. I built them all the same, and I'm going, oh man, this is horrible, because I didn't build the driving coil right, so I had to go back and build it again. That sucked.
Yeah, about every mistake teaches you something, and then you make less mistakes. So
yeah. Well, it was a pretty big one because none of it worked. So I've
been there.
I hooked up one of these circuits and nothing worked. I'm like, what the?
Oh, it's bad because you put this thing in beautiful resonance, right? This thing was like, dude, the best resonance I've ever had for any coil, right?
Mhm.
Did not touch the other ones at all. And I'm like putting my hands in shame. Like, what did I do wrong here? And then I realized it, and I looked at the number on the resonating thing, and I'm 100 kilohertz out of resonance for the other coil.
There was a burrito close to it.
Yeah, that was because now you have to add more wire to it, and you can't, so you have to build it. And then I overbuilt it and had to dewind it. It was a whole disaster.
You tried to build it to spec, so there was really no way of, now that sucks.
I should have known better. For as many of these things that I built, I should have known better. And I guess I just wasn't thinking about it. I was sitting there, man. I wind these things, right? And I hand wind them. So I take my hand and go like this on it, right? And it winds the coil on there. And I have to watch where they cross. Because where they cross over like this, it feeds it in flat. I don't move it over. So I have my wife's reading glasses on, right? They're at the edge of my nose, so I look like a really, really old man. They're like Fat Santa rolling, coils all day. And I could barely see the wire come over. And it was one after the other. So they take about 2.5 hours to wind one of these things because it's such small wire. Now, I should have just got a motor. I should have just hooked up the motor, sat there and just looked at it like that. Okay, didn't do it, paid for it, took forever. Let's see.
Yeah, a lot of love for the geometry in the chat. A lot of love for the deco. What did I call it? A decon? Let me see what Ian said back up here before I mispronounce it like you almost did.
I don't want that. I would have shortened it to about 4 letters with that, something like that. Anyway, so Ian, on that can, you have to bend a wire. I'm going to see if I have a wire here. So there we go. It's too short, obviously, but it still gets you the idea. You want to loop it like this and then wind it around where you still have that loop on it. And what that's doing is it's supposed to create more amps, okay? In that winding, put one of the connections from this, one goes straight to the cam, and then the other one goes to your full bridge rectifier. The one that goes to the cam, you just hook another clip on that, and that goes to the other side of your full bridge rectifier in order to rectify it. What you're essentially doing is you're making sure the can heats up. You're making sure the can gets as many amps as you possibly can, as much heat as you possibly can in that system. And you may find that bigger wire, the multiple more winds that you put onto it, get you more heat. So what happens with this energy is it's cold. So when it runs into a mass amount of any kind of metal, it will try to heat it up. Now the can's so thin, it's easily heatable. But if you said, okay, then I'll just take a big chunk of metal and put it in there. Well, it's not that easily heatable. Also, with the aluminum, it has an eddy current to it. So it doesn't like to stay on that aluminum at all. It likes to force itself away from the aluminum. In doing that, it also creates heat. So you're trying to take any advantage that we possibly can to create the heat. And that heat directly relates to your amperage that's coming through your circuit. So that's the way I see it. That's the way I built it. I'm going to be building another one here soon. And I want to use a bigger can, and then I'm going to use a quarter wave in it and amplify the energy that way as well. It should put it out a ton faster too. So hopefully that helped, Ian.
Dodecagon. Don't say that 5 times fast. I got to remember that. But no, don't say that 5 times fast. It's hard to say.
You could easily see where you can go wrong there.
Like I was stumbling on my words earlier. Luminiferous.
He says in the quarter wave makes sense. Yeah. Well, we're dealing in resonance values. So think about it. You're getting plasma if you create your coils 1-to-1, right? If they're the same frequency, you get plasma. Well, why not use that? You know what I mean? Why not? If it's creating that much out of there, giving all that extra for free, take it. You know what I mean? It means more conversion. So if you say, well, I brought my volts up a lot. Well, yeah, now let's heat it up some more and let's convert. You know what I mean? That's the way I see it. Yeah, harmonics. It's exactly what you want. Ian knows a lot about harmonics. So, yeah, he does that. Something of 9. I can't remember what he was saying, but it was pretty cool. But, yeah, he knows a lot about it. But, yeah, that's what we want to do. What if you wanted to call it some distance? Well, it depends how much distance you're looking for. I mean, if you're in good resonance with each other, you can go 8 feet, 10 feet, and it'll still pick up energy. So if you wanted to stop that, you need to find a barrier between it. And one of the things I wanted to look into was the microwave paint. And if it's good for your microwave, and then the little piece of steel that they put in there with the little holes, perforated holes you look through when you see in your microwave, I want to try that as well. And we'll see if it can slow down the field because you're making a waveform in there, right? Well, depending on your waveform that you're making and what size it is, you may be able to stop it. So both those things are interesting. Now they both deal in the energy from the microwave, which may be too high in frequency for those to work, but I'd at least like to give them a shot and try it. I do know 100% that the mineral oil will stop it dead in its tracks. And it's one of the only things I found that did it. So. Yeah. So another way to do your Tesla coil, I don't talk about this a lot. If you need to amplify your Tesla coil, but you want it to stop putting out so much energy outside of it, right? Well, you have to put it in I'm going to say the word wrong. I want to say captivity, but that's not the right word. You want to create a cavity. And basically you want to take an 8-inch pipe and put it over top of a 2.5-inch pipe that you wound it on. And you want it to stop it from going anywhere. You want that heat to stop. And then when the hot side of a Tesla coil does that, now, like I said, try some different methods of stopping it on the outside. Now you can put it in a small area where it's not going to affect the rest of everything else. When I did it at a 4-inch pipe to a 2.5-inch pipe, it would stop it for a while, and then it would be too close, and then boom, it'd shove it right out of resonance. So you have to kind of get some distance in there in order for that to work properly, but it also brings the heat up. So it'll also bring your amps up because, again, you're enclosing it. So your amount of distance between the center rod of your Tesla coil and the outside of your Tesla coil will also change in there because you're going to have so much more heat in that system that you may need a wider, number 2 coil on there. So 4-inch might be good with the rod down the center and an 8-inch barrier pipe. That might be perfect in there. And then you can obviously mess with it from there and adjust. But there's ways of doing it. But you just have to be, and that'll stop you, by the way, from making your body change the Tesla coil in frequency. And then detune it just a little bit. Yeah, detune it just a little bit because when it's so high and perfect, it drops off really fast. It goes right over the edge of the frequency, right? So you detune it just slightly so that it stays no matter if it goes up or down a little bit. You know what I mean?
That makes sense.
Yeah. That happens a lot. I trust me, I've had to work with all of it in order to figure it out because it's such a pain, Ben. When you walk into this thing and it's like, nope, we're out of resonance. Or you walk away, like something comes through, you're like, dude, did an ant? I mean, not an ant, but like a fly come by? Did something happen while I was gone? Like, I just ran over to turn off the light, which for me, by the way, if you see my experiments, it feels like an eternity because I'm a big fat guy trying to get over to the light socket that's way the heck over here. You know what I mean? Another room.
Or you're teaching people how to eliminate that temperamental, system, and how to, increase efficiency. And I had one more, and I just lost it. Not gonna lie, I had a total brain fart there. I was going somewhere, and I completely lost it.
Wrong bubbles. There we go. Yeah, got a lot of capacity. Sorry, man, I didn't read that right.
Oh, that's what I was gonna say. You're teaching people how to not blow stuff up. Like with your ZVS, boards and stuff. How you don't have to go through them as much as most people. You say that most people just run them for like 10, 15 minutes. And they just fry out. So
my boards don't fry. I run them for hours. So if you ever see me do a live thing, I'll go for hours. They won't blow up. I can use a Slay Exciter that I built. Man, my favorite circuit in the world. When you put one of these on there and you capture the cold energy in there, it kind of changes your thinking because all it is a simple PNP MOSFET, right? Or excuse me, a transistor. Sorry, I get somebody yelling at me for that. But anyway, it's funny because you're not adding capacitors to it. It just tunes itself and it stays in good resonance. You know what I mean? Which is the coolest circuit in the world because at 40 volts, normally things blow up. And trust me, with a lot of those 44Zs, I think is what they are, they do those things. I can't run them. I would be the most frustrated man on the planet running one of those things because as soon as you turn it on, 2 seconds later, it's smoking. And you're like, oh, okay, this is not fun. And then you go, can you hook 5 of them in there? Yeah, I have. And they still start smoking. So
that's just their signature feature.
Yeah. If I needed smoke for like a video, then I would just turn one of those on. That's about what they're good for.
It's like, hey, you got a fog machine? No, that's just a bunch of CVS.
That's bad.
He's like, hold your breath. You don't want to bring that in.
No, you don't want to look at that. I did it with my Variac one time. Ben, let me tell you, like inch-long sparks were coming out of that thing like everywhere. Yeah. I stopped running things with my Variac after that. I only run my AC with it.
I recognize now why Sean has that what is it, a fume machine that sucks up the fumes.
Yeah, he definitely gets a lot of those in there with that stuff.
I'm actually looking into it myself because I'm going to be doing a lot more soldering and stuff. So that's probably good. And I don't think they're that expensive either. I think I can get a small one.
Yeah,
that's going to be useful because I'm going to be doing a lot more soldering, putting together boards for people, and it's going to be fun. I love doing that.
Yeah, I got the big garage door. I just hit the button and open it and clear it out the room.
Yeah, that's nice. I like that. Have a garage setup where you just open the garage.
Yeah, well, it makes it convenient because then the heat and cold stays in here fairly well because the door is insulated, so it works out. Didn't experiment with a Faraday cage. I don't create that much outside there. Yeah, Sean would need a Faraday cage more than me. He's got big old bolts of lightning coming out everywhere.
Yeah. I told him he needed a personal Faraday cage just to wear one.
That's like pretty bad.
What was his name? David Blaine. I think he did that. He wore like a Faraday cage type device. But
like a chainmail?
Yeah, but the idiot, nobody told him that water's conductive, and he spit out water while he was being electrocuted by a Tesla coil.
He probably knew ahead of time.
Oh, you think he did it on purpose? Maybe it could have been.
Maybe he had like distilled water or some other kind of water in his mouth. You know what I mean? And it was not that conductive. He didn't have a lot of minerals in it. So yeah.
He just, it was funny because he spit it out and he's like, I got shocked.
Oh. Let's see. I've done that, taken the AC and cut it in half like a DC wave. And that gets about 13-inch sparks out of the top of my Tesla coil. That's when you see me running the Variac.
Yeah, that's when I had. That's when you had the video. That's when I had seen you had the video of the that board in the background where you were measuring the actual arcs.
Yeah, those things are monsters, Ben.
Yeah, you were getting more than a foot. That was insane.
What I wanted to do was build Sean's round Tesla coil because he's inverting the field, so it comes out as cold energy plasma. So you can see the difference. Yeah, you can see the difference in what he's doing with it. And those I wanted to figure out, you know what I mean, at very low amounts, what they felt like. You know what I mean? To see what they are.
Yeah.
And then, man, if they're not really a whole lot of hurting to them, you know what I mean? Like Spider-Man, just right there.
You know what that Death Star.
I get in trouble, Ben.
You know when that Death Star coil is lighting up with the plasma sticking out at the end? It reminds me of, if you grew up on cartoons, you know, those old school like bombs. You see like a bomb with the, you know, like little sparks sticking out. Always reminded me of that.
Yeah. Yeah, it's pretty dangerous. I don't know. Maybe it's a bad idea altogether. I should just stop. Maybe buy a mannequin and you use that to see if it'll shoot out the fingers of the mannequin. See if it burns.
I think the real interesting thing happens when you have like conical shapes. You know, we heard I think it was Bedini talking about going inside that room full of inventions, and there were a lot of like conical shaped coils, and I don't know, that something with cone shaped and that shape of focusing the energy in the tip. I don't know. Maybe there is something there. You know, like the pyramid power.
Hold on a minute. I'm going to show you real quick Sean's coil. He just finished. He's got, I think, 4 of these things. So he's got the cone shape.
Look
and
at
he cut
that.
the
That's
top
cool.
off. I'll hit play. Yeah.
They're so pristine. Look at that. They look like artwork.
Yeah.
The epoxy layer is just so perfect.
Yeah, he said he changed his method on it. So
Wow.
when he presents, he'll show it to us. He sent me this. So take a look.
Yeah, it just looks like it's glossed over like a professional gloss. It's so cool.
Yeah. No thick layer at the bottom, so I think he's going to try to see, what capacitance he has to put into it now.
Yeah, because the epoxy, I think he was saying maybe was affecting the system because it's maybe acting as a capacitor.
Yeah. So I'm just interested to see what it does now. So 2 of these pointing at each other. Let's see what, you know what I mean? The interacting, if it does interact, the plasma.
Yeah, too. Yeah, that would be cool. I just can't get over how awesome they look. It looks like a professional manufactured piece. You know, like something that's like professionally manufactured and you would sell.
Yeah, he sets it in the vacuum, by the way, just so everybody knows. I don't quite see any bubbles in this one, but he has had them in the past. So, yeah.
Yeah, I guess you got to be careful with that.
Yeah, so he definitely puts them in the vacuum chambers and tries to get rid of all of them. Because an air bubble in there is just hot. It just makes heat. It'll start frying wires.
Right. Is that when you see like kind of like that outbreak on the side?
Well, it could be in the inside, everything, but if you've ever made an AC flyback, which is basically the winding he's putting on there, then the biggest part where they ruin each other is one wire next to the other. It'll melt the insulation on them and it'll fry. And it'll be in seconds, by the way. It won't be in minutes. It'll be in seconds. It automatically does it. That's why finding a good AC flyback is important. I found one, man, that goes all day. It's the best one I've ever seen. Tesla used something that was self-healing. I don't know that Tesla had, I don't want to say it, on the outside, he didn't have individually insulated wires. If I'm not mistaken, they were bare wires, and then he used something else to put on them later. Now, I could be completely wrong about that, but I thought I read that somewhere.
It's possible. Yeah, I honestly don't know. I know that his giant pancake coil was just, a tube that was, wound up in a spiral, right? Or two tubes.
Yeah, it could have been. I don't know. This right here, by the way, this is the ZVS board that I use. And it's got these caps on it. Here's what Sean told me today. And they said, yes, Ben. I believe you're right. These capacitors, if you take off all of them, they're running parallel right here. Sean said to take them off and put 4 of them in series, and you can run your Tesla coil with it. So you don't have to buy expensive caps. Just take 4 of them, run them in, one right after the next to each other. Instead of being in parallel while they're connected, like that. But that's interesting because it saves me what, $40 every time I run one. So
Yeah.
I'm gonna have to see what the resonance is on one of those. But he said he did the math and it works.
Yeah, Sean's good with the math. I'll tell you that much. I'm not like him. I struggle with the math sometimes, but his math always is on point. So I'm sure you guys will have some kind of positive results with that.
Yeah. By the way, if I took my circuit right there, my flyback, not my flyback. If I took my GBS and I put in capacitors for a Tesla coil and then put it to your flyback, oh man, aren't we having fun? The frequency changes quite a bit. 200 kilohertz is what I was getting out of it. I was trying to make less amps out of it, and so I changed the capacitance on it, and it sure did make less amps. That was pretty cool, man. It was an awesome effect, but it definitely works.
That's awesome.
Wax and tar. Maybe that's what they use the beeswax for, huh?
Maybe.
I don't know. I haven't read up on it a lot, man. I've been involved in doing stuff. That, and I've been on grandpa duty. So
Yeah.
chasing after my granddaughter everywhere. And trust me, it's not getting any easier with age. So, all right, guys. Sean will be back next week. And everything that he's doing, man. So we're going to rock it out with him. And then Friday, we're going to be seeing Mike. We'll be on Mike's show together. And then on Saturday, Joe and I are going to kick it off. I don't know what adventure we're going on this week, but it should be a good one. And then that's pretty much what I got going on. What do you got going on, Ben?
I'll see you guys for Free Energy Fridays. I should have the presentation ready for Walter Russell's New Laws of Thermodynamics. Probably a quick pregame show, something fun, just to go over, some of the simple basics of how the science, it's not contradictory, it actually all adds up. So it should be fun.
Interesting. I want to check that out for sure.
You can check that. Yeah, and if you guys are interested, you can check that out on my channel, Beneficence TV, on YouTube. I can put the link in the chat if you want, real quick. But it's basically how you spell it on the tag underneath my camera.
Right on, man. All right, guys. I want to say thank you to everybody in the chat. Hopefully, I answered quite a few questions today, and hopefully, the hit video was helpful for you guys in your experiments. That's kind of the goal here. Hopefully anything that we build that you guys can build the same and start putting stuff together and maybe throw your own spin on it and show us back. And then, we'll invite you on to take a look at things and see how they work. But anyway, I hope everybody has a great day. I want to thank everybody.
Yeah, thank you guys. Thanks, Nathan. Thank you, Nathan, and thank you, chat. It was an awesome stream.
Yeah, we're looking forward to Gerald when he comes back too. I agree with you. Right on, guys.
Yeah. Have a good night.